Math 120, Section 5.1 Highlights. In this section, we will understand open intervals, determine where a function is increasing, both graphically and algebraically, determine where a function is decreasing, both graphically and algebraically, understand when a function is constant. Find critical numbers and use test points to determine where a function is increasing or decreasing. First, let's define open interval. An open interval is an interval of values where neither end is included. Always use x values and open intervals when describing where functions are increasing or decreasing. So by open interval, just on a simple number line, what we would mean are the points in between certain values, not including the endpoints. So it's the values in between. Both ends are not included, and it would be written 2, 3 with parentheses on each end. An open interval can also be an interval that involves infinity. So we may have an interval from 5 to positive infinity, and it would be written 5, infinity. So whenever we are describing increasing, decreasing, or constant, we will use these open intervals, which mean endpoints are not included, so parentheses must be used on each end. Now, where is a function increasing? A function is increasing if its graph is rising. This is where f of x2 is greater than f of x1, where x1 is less than x2. So we have x1, which is less than x2 on our number line, and we have f of x1 and f of x2, which are our y values. If between these points, f of x2 is higher or greater than f of x1, the graph is rising and that function is increasing. So we're just looking between two specific points of x, and we would describe it as increasing between x1 and x2. But f of x1 has to be less than f of x2, or f of x2 is greater than f of x1. A function is decreasing if its graph is falling. This is where f of x2 is less than f of x1, where x1 is less than x2. So again, we have an x1 and an x2, and between these, the graph is falling. Now, the graph can be doing other things here and here, but we're just looking between x1 and x2. And you'll notice that f of x1 is lower than f of x2. So with x1 on the left and x2 on the right, f of x2 is greater than, it has a higher value than f of x1, which tells you that between x1 and x2, the function is decreasing. Now, a function is constant if f of x1 equals f of x2 for all x in the interval. If this is the case, the graph on the interval will be a horizontal line. So if you had a function that was doing something like this, and here's your x1, and here's your x2, well, there is no change between x1 and x2. f of x1 is equal to f of x2. Those y values are always staying the same no matter where you are on the interval between x1 and x2. So here we would say this is constant. The graph is a horizontal line. We'll be using critical numbers. Critical numbers for a function f of x are numbers we call c that have to be in the domain of f of x, where f prime of c comes out to 0, so you take the derivative and at that specific number the function is 0, or f prime of c does not exist. Now it's important to remember, to be a critical number you have to be in the domain of the original function. If we want to define a critical point, it's going to be c and f of c. So you put c back into the original function to find the critical point. Using test points to determine if a function is increasing or decreasing on an interval. The first thing we do is set f prime of x equal to 0 to find critical numbers. Remember that critical numbers must be in the domain of the original function. We're going to graph them on a number line. We will choose a test point we'll call t in each of the intervals that are created by those critical numbers. We'll look at the derivative at the value t, and if f prime of t is less than 0, f of x is decreasing, and if f prime of t is greater than 0, f of x is increasing. So less than 0 is decreasing, greater than 0 is increasing. So let's look at a few examples. Example 1. Find the open intervals where the function graph below is increasing or decreasing. The words open intervals mean parentheses on both ends. What we will do in this case is we'll just follow what's happening to the graph. If you look at the graph here, you will notice that the graph is falling from left to right. We have to describe those x values for where the function is decreasing. And starting here, the function is rising, and those are going to be the values where the function is increasing. So the function in this case is increasing. Looking at x values only, it starts at -4. So -4 to infinity. Because for all of these x values to the right, the graph is going up. Now we're not looking at these y values. We're looking at what happens to the y values, and we're describing these x values. This function is decreasing from -infinity to -4. And notice in both cases we use parentheses on both ends. So answer A is -4 to infinity, and answer B is -infinity to -4. Example 2. Find the open intervals where the function graph below is increasing or decreasing. So we'll do increasing first. Remember, that is the x values where the graph is rising. So I'm going to highlight rising graph to here, rising graph to here. But remember, I am using x values only. So from -infinity, it's not because the graph is going down here, it's because the x values are coming from this direction until I get to this x value. So negative infinity to 2, open interval. And also, it's rising again from 4, all of these x values to the right. So, comma, 4 to positive infinity. So the graph is increasing from negative infinity to 2 and from 4 to infinity. Now this graph is decreasing because there is a section or interval of the graph where it is falling. This graph falls from this x to this x. So this function is decreasing from 2 to 4. And that's the x values here where the graph is falling. Here we're to find the open intervals where the function graph below is a increasing or b decreasing. The graph will be increasing if the graph is rising. So we're rising to here, and we're rising again here. Describing x values only, this x value is negative 7. So from negative 7 to this x value, which is 0, and again from this x value, 7, to positive infinity. This is where the graph is rising or increasing. Now this graph is decreasing where the graph is falling, and it falls again in a second place. So it is decreasing, looking at x values only, negative infinity, until I get to negative 7, parentheses on both ends, and again from 0 until we get to 7. All endpoints are excluded, so use parentheses on all of your intervals. And also remember to use x values.